Good morning, everyone. Firstly, I would like to introduce myself. My name is Alberto Satrio Wichaksono, and I'm here to present the article with the title Effect of Capillarity Direction on Solar Still Performance, written by Alberto Satrio Wichaksono and Mr. F.A. Ruti Sambada from Sanata Dharma University. We begin with the introduction, which explains the background for this research. The demand for clean water follows with the increase in population, especially in rural areas where existing water sources are polluted with substances that may be harmful to our bodies. There has been many solutions to combat this problem, one of them being a cheap and easy to use alternative, which is the solar still. The solar still is used to convert brackish water into clean water. However, this comes with a problem. This method has lower efficiency compared to the others. Next, I will explain an overview of the solar still and how it works. On the left side is a picture of a side cross-section of the conventional basin-type solar still. Water is filled at the absorber, which is located at the bottom, which is then heated and an evaporation process will occur, turning water into steam. The glass at the top has a lower temperature compared to the inside, which then condenses the steam into water droplets. The water droplets then flow to the bottom end of the slanted glass, resulting in distilled water. Since the efficiency of conventional basin-type solar still is so low, in this research some modifications will be made in order to increase the efficiency of the solar still. It is classified into three variations. The first one, which is interfacing layered with tissue with capillary direction from the sides, and the second one, interfacing layered with tissue with capillary direction from the middle or inwards, and variation number 3 with interfacing layered with aluminum with capillary direction from the sides. This is an overview of the modified solar still. The picture on the left is the side cross-section. The blue bar indicates the elevated rubber, which is then layered with tissue or aluminum and varied by the direction of the capillarity. This method is used in order to increase the water temperature much faster while also maintaining the volume of the water through capillarity. The middle picture shows variation number 1 with capillary direction from the sides, and the third picture, or the most right picture, is version number 2, where the capillary direction is from the middle or inwards. Next, we'll be discussing on the method of this experiment for this research. First of all, each solar still variation is filled with 1 liter of water. Since this experiment is done indoor, heating lamps are used to simulate solar radiation energy with a radiation intensity of 712 watt per meter squared. This experiment is conducted for 2 hours for each variation. Efficiency is calculated with the formula below. Water yield multiplied by the vaporization latent heat divided by solar radiation intensity multiplied by the absorber area, in this case 30 by 30 centimeters. Data is then collected and made into the graph. This is the graph of the water yield accumulated from the distillation process. This graph shows that the conventional basin type solar still has the lowest amount of water yield accumulated within 2 hours, being 76 milliliters, with the highest being variation number 2, which is the interfacing layered with tissue with capillarity direction from inwards or the middle, which accumulates a water yield of 124 milliliters. It is then followed by variation number 3 with 102 milliliters and variation number 1 with 98 milliliters. After, after finding the water yield, we can calculate the efficiency of the solar still. The conventional basin type solar still produces an efficiency of 32%, being the lowest out of the variations made. The highest efficiency is produced by variation number 2, being 53%, followed by variation number 3, which produces 43%, and the remaining variation, which is variation number 1, with a value of produced efficiency of 42%. From the data above, we have come to a conclusion. The first point, the highest water yield and efficiency is obtained from the interfacing layered with tissue with capillarity direction from the middle or inwards, which is variation number 2, accumulating a water yield of 124 milliliters over the course of 2 hours, producing an efficiency of 53%. The second point being capillary direction affects the productivity of a solar still. The inwards variation has shown an efficiency of 53%, which is a much higher efficiency compared to the sides variation, being an efficiency of 42%. The third point, layers with different transmittivity affects the productivity of a solar still. The aluminum layer variation produces a slightly higher efficiency, which is 42%, compared to the 42% of the variation which is layered with tissue. That is all for the presentation. You may ask questions and follow as procedures for the Q&A. And final words, thank you for all the attention for this presentation.